fixed, but there's still more out there. And the problem with finding bugs in hardware is that what do you do, right? You go to a client and you explain that. Are they going to make the decision to replace every one of those devices? Or so it's a much more complex problem. You can't push a software patch for a lot of those types of issues.
Your 10,000 thermostats are really, really bad, and they need to go back. And you need to go roll trucks out to every house and swap them out with this newer one, right?
Jeff, probably the most interesting thing about Zigbee that we liked about it is that as a known and understood protocol, if you can find a way to get onto that network, right? So that would be using the types of tricks that we talked about, where you're actually reading keys off of a device, doing something where you can get the necessary information to join a network or impersonate a device on a network. Once you've got that, you're basically sitting at at an API for that meter and for backend stuff that's way upstream from that meter. And so you get all kinds of interesting types of things. Like we played around with ideas about, right, so SQL injection via Zigbee, right? Yeah. And being able to shove all kinds of interesting inputs back up into these API functions.
Yeah, so you have ultimately the Zigbee data that typically is being collected over a home area network is things like usage and load for different consumer devices, and I always just like simple description. This is the thing that's going to essentially tell you someday, if I guess that matters to you, via email that you left your refrigerator door open, right? So it's it's going to see these the patterns of usage across all your devices and stuff. So there's things like there's device name and all these other pieces that are being sent over that protocol upstream, and those are actually populating like web interfaces inside a utility, and those those web applications may or may not have any validation.
Right. So you potentially have ways to trigger bugs all up that stack, right? So from simple buffer overflow type stuff on the meter itself, or the device itself, whatever it is, all the way upstream.
Okay. So somebody go home and name your meter, or name your thermostat TICOR 1 = 1, and see what happens. If you get a call, then
but sort of the end run though is that we actually really like Zigbee. That all these things said about it, being an open stack that has had a lot of smart people look at, it's pretty well locked down. And you start trying to dig into how SEP works, and it's just riddled with PKI, and there's going to be implementation issues, and we'll probably find design level issues over time. But it's the best thing we've seen at that layer. I understand. I've gotten into discussions with both the vendor side and the utility side about why there are practical reasons why Zigbee's shouldn't be used for other types of transport. Largely the same types of issues we talked about earlier with being able to blanket an entire large area with high levels of packet loss. But at sort of the paper level, it's really about the best that we've seen.
Yeah, and really for us, and we feel like that's substantially a benefit to utilities, and really ultimately to everybody. In our case, in reverse engineering like proprietary radios that had zero documentation and vendors that hung up on us when we asked questions, that was 3 and 4 months to get to the point that we got to in a few hours with Zigbee. And ultimately that point is getting to the point of finding bugs and helping the utilities and the vendors, whether they like it or not, fix those things, right? So I'd much rather have that personally, and know that you have that kind of access. And yeah, like Nathan said, I see that as being something that'll be kind of iterative, where we'll run through and see improvements there. And the problem is that for proprietary radio stuff, you go through that same process for every vendor over and over again, every time. And we know for a fact, and I see some people in the back of the room, that all of us, shops that do this are going around to utilities and telling them these things, and the other shops are telling the utility the same thing, the utility's telling the vendor, and nobody's telling anybody else, right? Whereas with something like Zigbee, when flaws are found, even if they're, maybe, mushroom cloudy flaws, I don't think they would be, I'm just being facetious, the reality is that we're all going to know about it, and we're all going to see it get fixed. And, and actually we mentioned SEP v1. That's one of the other things that's coming down the pipe is SEP v2 that adds a lot more components to that whole stack.
Yeah, I've not spent a ton of time looking at it, but just sort of as an FYI, it seems to be primarily around API stuff as far as what people really care about. There are some other under the hood types of changes, but largely it's about rolling out new feature sets to what can happen on that network. I mean, talking about like how SEP was also the application layer, as well as components of the application layer, as well as transport and all that stuff.
Now, on the other side of that, we mentioned it being the fastest path to fuzzing a meter. We really like the concept of, and utilities don't necessarily because they're going to be looking at the maintenance side of that. But essentially, if you think of on the AMI side of smart meters, that really what you have is kind of one NIC that talks to neighborhood area network and another NIC that talks to the home area network. And that NIC is, in a lot of cases, a ZigBee NIC, right? When you enroll devices in the device management of all that, and we didn't actually touch on that a whole lot, but like one of the big things about ZigBee that is, OMG fail is that the key exchange pieces of that are done over the air and those keys remain static, for a long time. So like how enrollment happens. But when people are taking things and they're burning the keys into the device because the utility controls them, and they're doing that beforehand, we can't sniff a key go over the air, right?
Right, and that, for example, that's one of the things that SEP mandates. So that even while ZigBee will allow you to do dumb things like send keys over the air, SEP will say, no, you can't do that. You have to invent some sort of outside, out-of-band pathway to make that occur.
Yeah, or extract keys, obviously, from memory, and
right.
And we all, I think we've talked about that. But so yeah, what we like is really, in the case of a consumer to HAN gateway, what you're seeing is essentially a little box that box is the one that can talk to the meter, and the consumer can enroll their own stinking refrigerator, right? And they have control over those pieces, and that adds some separation between the utilities network and the consumer. And I kind of like it too because it also tells me that, and if you look under the hood on things like SEP, in some cases, those devices that are on your HAN and that are ZigBee enabled, ultimately, if they so chose, right, your utility, and in some cases, people are being offered like a lower utility bill to agree to this, that the utility can shut off your air conditioner if they have a high load time, or that you agree to that for certain times a day. I don't really want that, No, my house is hot. So, in the case of a consumer gateway like that, you might have more control there over what's going on. Maybe not. Yeah.
So yeah, just a complex picture of what that ZigBee thing that's not OSI looks like.
Yeah.
Right.
So yeah, essentially down at the bottom you have a low-level network protocol, and then you have these different profiles that are built on top of it, right? And so think like a 4-layer like DoD model or something like that. Oh.
Okay, so specifically to focus in on FHSS, because that's one of the things that we've seen the most often as transport for some of the interesting things we've looked at. So talking about the way these things work, you think about, when we got into this, we didn't know a whole lot about RF. So we learned a lot over like 9 months. So just as a sort of a quick primer on it, FHSS means that for any given transmission, you're bouncing around multiple different frequencies within a band. So in this case, within ISM bands, so like 902 to 928, something like that, there will be a certain number of channels within that have a pseudo-random hopping sequence, right? And so when I send a signal over, it'll send a certain number of packets, and then it'll hit or a certain amount of data, and it'll hit a threshold, and it'll packet that and throw that over one individual link. And both sides are synced up as far as what their hopping patterns are. So usually it follows some sort of an algorithm that's programmed into the firmware, and it'll take something that it knows as some sort of a static value, and then can use that as sort of a driver for some sort of algorithm that tells it where it needs to be. And then so they just hop together in sequence throughout this band. And in general, it came around in World War II as a way to get around narrow band interception. And that it can be difficult to listen in on those types of communications because you don't know exactly where the signal is going to be, right? Just do wideband interception, right? So while in World War II, or let's say even today, a lot of people that are working with this kind of stuff are doing little devices, basically. They will go out and buy the same chip that's in use, or desolder a chip or something along those lines, and build a little board that allow them to test that and talk comms with whatever they're wanting to talk to. And so that's kind of the way that it's been done for a long time, and that was the only way that you could really